we go. Remember the numbers in front of a balanced equation. They have two purposes. One is kind of your conservation of mass. The number of atoms on the left side of the equation have to equal out the number of atoms on the right side of the equation. But those stoichiometric coefficients are what we use within stoichiometry to convert from one thing to another. Now, I briefly showed you an example of this for the molar volume lab. But that was a 1-to-1 ratio, and we just said, hey, the moles of magnesium are the moles of hydrogen. Finish the lab. Now we got to be prepared for any type of ratio. So again, what that balanced equation says, which is the equation for the synthesis of rust, Fe2O3, iron 3 oxide is just rust, is that for every 4 moles of iron, it requires 3 moles of oxygen to create 2 moles of iron 3 oxide. So if we were given moles of anything in that equation, we could convert to moles of anything else using the ratios from the balanced equation. However, it's uncommon that you start with moles. Moles is kind of the middleman in all of chemistry. So what we did in Chem 1 was we went from grams of one thing to grams of another. And that's what we're going to start off with today. However, later on today, and not in the notes here, we're going to go over the fact that if you know the molarity and the volume of a solution, molarity times liters equals moles, you can also use these conversions in order to figure out what you would need to figure out. So again, hopefully I don't go too quick through this, but I've got a whopping 2 more slides to go, and one of them is just a practice problem. I want to kind of refresh your memory on stoichiometry, but then in my mind, you got to do the math to know the math. So a reminder about the 3 steps, and if you don't want to write this down, you don't have to, because then my last slide is a practice problem. That might be better for you. Is what we're going to start off with today is I'm going to give you the grams of something. It could be a reactant, it could be a product. It doesn't matter. The nice thing about stoichiometry is you can relate one thing in a balanced equation to another thing regardless of where you go. Steps 1 and 3, where grams to moles are involved, is just using molar mass from the periodic table. The second step, when you convert from moles of A to moles of B, that is what stoichiometry is. And stoichiometry is using those stoichiometric coefficients to convert from one thing to another. It is not really the 3-step process that we show you in Chem 1. Although that was a very common 3-step process, that's one that we can use as well. But really, it's that middle step that once you use a balanced equation with its coefficients, you are doing stoichiometry. And you could be given moles of one thing, convert to moles of another. Wouldn't that be nice? So, to wrap things up, I want to give you one sample problem. And then let's have you guys work on this a little bit today. So here's the equation we're going to work off of. This is a little bit different, but it is a single displacement reaction. It's not an ionic solution like you'd typically think of with a single displacement. However, it's an element in a compound, more than one element within it, creating a new element in compound. If you put calcium in water, you can create hydrogen gas. I actually used to do this reaction with udiometers. So here's the question that we're going to solve. Okay, maybe you don't have to write down the full question. I'll show you another way we can kind of write this out here in a minute. The question says how many grams of hydrogen are produced when 11.5 grams of calcium are added to an excess of water. In order to do stoichiometry, you need a balanced equation. So if anything, I would say write down the balanced equation, and then we'll take it from there, and I'll rewrite that here in a second. Keep in mind, it's fairly common that you're given the balanced equation on AP exams. So unlike Chem 1, where we made sure to make that a point of emphasis, and I'm going to just rewrite that balanced equation so I can show the entire problem. It's fairly common that you'd be given the equation. I mean, the worksheet that you're going to work on in a little bit, I'm going to have you practice writing the equations. Question gave me 11.5 grams of calcium. and it was asking for how many grams of hydrogen. This is one way that I can just summarize that question right there. Here's what I'm given, here's what I'm solving for. Now, if I go back to the question itself, at the very end it says, is added to an excess of water. That way of wording it is going to come into play when we do limiting reagent next week. Actually, not next week, because we only have one class period next week. So the week after, I suppose. So that wording, don't worry too much about right now. However, recall what our steps are. Write down what you're given. Step number one, again, when in doubt in this class, convert to moles. 40.08, yep. Again, if you are not comfortable continuing the conversions, feel free to just hit equals and get your moles of calcium. However, in Chem 1, most people, after a while, just start stacking their conversions one after another. Once you're in moles of calcium, you can convert to moles of hydrogen. Okay, notice that's a 1-to-1 ratio. Now, a lot of people don't like showing this conversion. Some people, it's pulling teeth to have them show any work. However, one of the things that when I took an AP course way back when, that the instructor told us is when they're grading, they're looking for you to demonstrate an understanding of the topic. So showing work is that demonstration. The final answer isn't good enough. So I would like us to get into the habit of doing it, even if it is just a 1-to-1 ratio. Keep in mind, I could have asked how much water is needed to react completely with this, and then it would be a 2-to-1 ratio. After step 2, however, grams cancels out calcium. You'd be in moles of hydrogen. I want to get to grams of hydrogen. Remember, hydrogen is a diatomic, so it's 2.02 grams in 1 mole. Again, the entire point of conversions is to get those units to cancel out. Now I'd have grams of hydrogen as my final answer. You can kind of plug it in and solve. And I think I have written down 0.580. I typically suggest not only writing grams, but grams of what for your unit, because recall in stoichiometry, I could solve for anything in that balanced equation. It doesn't have to be reactant to product. It can be reactant to reactant, product to product, product to reactant. That's the nice thing about those ratios. It works for relating anything together. Is this ringing a bell? Kind of?